Hello guys. So today we're gonna learn about a fifth experiment that is multiple layer perceptron. So let's begin. So in this first we're gonna import the data set which is imported from sklearn.datasets load digits. So here we have loaded it and then we are checking the total samples and also the total number of features per sample, that is basically the shape of the data set. Uh, Here in the output, we can see that the total samples are 1797 and 64 features per sample. So in the next second question, we are asked to choose independent variables x and dependent variable y. So in that, we are going to separate x and y. So the data and the target variable, which is dependent variable. This we use so that it is because it is important in machine learning. Because the models learn the relationship. This model particularly learns the relationship between the dependent variable and the independent variable, and the shape of the dependent variable and the independent variable is 79764 and 797, that is the target variable. So in the next question we are asked to standardize the input variables using standard scalar. So why do we use standard scalar? Because this converts the data into standard normal distribution, that is mean equals to 0 and standard deviation equals to approximately 1. So this is important because neural networks are sensitive to scale. That means if the values are not in the same scale, that is not in the same range, then same range, then the output or predictions may vary, and which causes a error, and that leads to inaccurate predictions. And let's go forward. In the fourth question, we are asked to split the data into training and testing data. Here we are, if you check out the code, here the test size is 0.2. That means 20% of the overall data set we are using as test data set, and the other 80% we are using as training data set. This ensures that model can generalize to the unseen data to avoid overfitting, or in easy words, to by heart the outputs, to memorize the outputs. Yeah. So in the next question, we are asked to convert these variables to torch tensor. First, we have to import the torch. Then we have, as you can see, converted this train x train variable and x test, y train and y test into torch by torch tensors. Sorry. And next, we have to define the MLP model layers and configuration. In sense, we have to create an or define an ANN model, artificial neural network. Multiple layer perceptron is a uh, very basic artificial neural network, we can say. So in this we have in this it includes input features, hidden layers, and output layers. Input layer takes P features and performs computation using activation functions like RELU, and output layer gives predictions in the range of 0 to 1, and the 0 in the range of 0 to 1 using sigmoid functions. This allows model to learn complex patterns, and here you can see the model is defined in these layers. In the next, we are using training this data using training the model using back propagation. Uh, in this step, I train the model using the training data set, and the model learns patterns over multiple epochs. Epochs in this scenario are called as iterations. Each epoch means one complete pass through data, one iteration. The training process updates weight using back propagation. In this, we have optimizer that adjusts weights efficiently, loss function that is used for classification, and training underscore error is used to keep a track of the error or loss. Next, so this model is trained over multiple epochs. Done. Now we have to plot the loss, this loss onto a graph. So this loss represents the error in predictions. A decreasing loss indicates that the model is learning, and as you can see, the loss is decreasing over the as the number of iterations increase. This helps model monitoring the model performance. And next, let's test the model. So here, after training, I'm using this model to test on data. So as you can see, we are using the, as we have split the data into training and testing data, we are using uh, independent variable X testing data that we have segregated to make predictions, and the output will be in the probability form, which is 0 to 1, which I convert into binary values of 0 to 1, 0 or 1, sorry, using a threshold. Next, as you can see, we don't have much of an output over here, so I just gave the testing complete prediction so that I may know that this cell has run and has completed its execution. So in the next, we have to evaluate the model using confusion matrix and other performance metrics. For that, first we have to import the confusion matrix, accuracy score, precision score, recall, and F1 score. So for that, we are using the testing data. We are testing the accuracy. So we are using testing data and also comparing it with the predicted value that we have predicted over here. So to plot this, okay, then after that we are printing all of this. So as you can see, confusion matrix and accuracy we are getting as 0 0.9, 0 0.9, 0 0.9. Uh, so that's it from my side. Thank you.